Hello, welcome back to the Summer Virtual School. I'm Mrs. Smithy and I teach second grade at Stockwell Elementary. We are on day 4 of our math lesson. So today you are going to need your day 4 worksheet and then a pencil a little bit later. And our code word today is Twix. So go ahead and write that down on your worksheet. For our refuel today, we're going to do something a little bit different. It is called mindful listening. And when we mindful listen, it helps us learn how to block out distractions and be able to really focus on what it is on one thing at a time. So we're going to practice this mindful listening video together. And you don't really need to see what's going on because you can close your eyes. But remember, we're going to focus on our listening.
Mindful listening. Begin by sitting in a comfortable position. You might want to close your eyes. Listen to the sound the bell makes until you can't hear it anymore. When the sound stops, raise your hand. Now, with your eyes closed, begin to breathe naturally as soon as you hear the bell. Count how many breaths you can take before the bell stops. Notice how your body feels. When you're ready, open your eyes.
All right, so that is something that you can practice at home, just focusing on one sound at a time and trying to block out those other distractions, especially while we're at home right now. There may be other things going on around you, and just being able to focus in on what it is that we're doing. It's good practice. All right, so our target today is I can use addition and subtraction within 20 to solve real-world problems. I can represent my answer using drawings and equations. Now this is the same target we had last time, except this time we're going to be using both addition and subtraction. We're going to be able to meet this target by giving evidence to support our answer. Our evidence can be our drawings, our models, writing an equation with a missing part. So again, we're going to use that representation to create an equation. And then we're going to solve the problem using addition or subtraction. So you may be able to do it. You may have more than one way to solve the problem today. All right. So we're going to review. We kind of talked about bar models a little bit at the end of last lesson. But let's think, what is a bar model? And I have one of my favorite chocolate bars up here to kind of show you that a part whole model or a bar model is really just showing a whole and then parts or pieces. If I have both of these Twix pieces came in my package and I have one that's whole and this one came broken, it's kind of a bummer because when your candy bar's broken, it's not always the best. But does it mean you got less chocolate? No, it just means it looks different, okay? So when we look at a bar model, we may have a one big whole number, but then we also can show that we can break that number into smaller pieces. Just the way it looks is different, but it's still the same value. So when we use a bar model or a part whole model, we usually show the whole and then we show the parts. Now for this one I have 2 parts, but you could have 3 parts or 4 parts. It just depends on what the word problem is having you do. Now, all of the parts equal the whole, so that's very important that we understand that. Last time we practiced some problems where it gave us the parts and we had to find the whole. And then when we found that missing whole, we added them together and we created an equation. The part plus the part equals the whole. Well, today we're going to be working on some what we call missing part problems. This bar model has a whole and it has a part, but it's missing the other part. So when we find that missing part, there's 2 ways we can do that. We can add to get to the whole. So we can take the part that we know plus how much equals the whole. So we can add to find that part. Or we can subtract. We can take what we know is the whole, take away the part we do know, and then we're left with the part that's missing. So if we plug in some numbers, this is kind of what that would look like. Over here, just like last time, we had our 2 parts. We had 5 and 8, and we were missing the whole. So what we did to find that answer was we added the 5 plus the 8, and that gave us our whole. Well, if you're missing the part, you can use addition. We could say, I'm starting with 5. How many more do I need to add to get to my whole, 13? Or we could use subtraction. We could think, okay, I know I have 13 as a whole. I know part of that is 5, so if I take away the 5 I do know, I'm going to be left with the other part. So those are both ways we're going to be solving those problems today. We're going to watch a Learn Zillion video, and as you watch this video, I want you to be thinking about this question today. If you and 5 friends solve a problem, you're solving the same problem, will everyone's evidence look the same? Okay, that's what I want you to think about today.
Some birds were sitting in a tree. 6 more birds flew over. Then there were 13 birds in the tree. How many birds were in the tree at first? How do you solve this problem if you don't know how many birds you started with? In this lesson, you will learn how to solve a problem with a missing part by drawing a bar model. Now let's review what you already know about making a bar model. You can follow the model drawing steps. You also know that a bar model is a picture that we can use to help us understand the information that's in a problem. Here's an example of one. Instead of drawing 3 strawberries, I could just put 1 rectangle with a 3 on the inside. If I get 5 more strawberries, I can just add another rectangle with the number 5. Now you can see that my 5 rectangle is bigger than my 3 rectangle because 5 is more than 3. You can also see that I have 1 part, another part, and if I add those together it equals the whole thing. So to figure out that question mark, I can just do 3 plus 5 and that equals 8. So I know there are 8 strawberries in all. Let's look at our word problem again and follow our model drawing steps to figure out the answer. First step, what can we do to make sure we understand the problem? Well, we already read the problem, so now we're going to turn our question into a fill-in-the-blank sentence. Listen to the question and think about how you would answer me. How many birds were in the tree at first? You would probably say back to me, there were blank birds in the tree at first. Because we don't know our answer yet, we just put a blank space. Next step. When you were reading the problem, who were you imagining? The birds. What were you imagining? The tree. So the name of this model is going to be Birds in the Tree. Now we're ready to chunk and draw. Now remember that when we chunk a problem, we're looking at one chunk at a time. Because if we look at too much too fast, we might miss something. So I'm going to read the problem, and I want you to say stop after each sentence so we can think about what we just read. Some birds were sitting in a tree. Stop. I'm going to put my slash mark so I don't forget where we stopped. Now, I see that it says some birds. How many birds is that? Well, the problem doesn't tell me, but I still need to show this information in my model, so I'll just draw a rectangle, but I won't put a number on the inside because I'm not sure how many birds there are. Let's keep reading. 6 more birds flew over. Stop. Now, I see that there are 6 more birds, so I'll add another bar and put a 6 on the inside of it. Let's look at the next chunk. Then there were 13 birds in the tree. Stop. Now, are those 13 birds part of my birds or all of my birds? 13 represents all of the birds, so I'm going to write 13 over the entire model. Let's look at the last chunk. How many birds were in the tree at first? Stop. Since this is a question, I need to put my question mark somewhere on the model. Well, I know that when I created my fill-in-the-blank sentence, I was trying to figure out the number of birds in the beginning. So where are those birds? Looking at the model, I can see that that first rectangle is blank, so I think that's where my question mark should go because I think that's the number of birds in the beginning. Okay, now I'm done drawing my model. Now I'm going to compute the answer. This just means that I need to do my math. So let's use our model to figure out the answer. I see that there's a part here, and if I add them together, it'll make my whole. So I can just make an equation out of my model. Question mark plus 6 equals 13. Now I actually think I can use my doubles to help me figure this out. I know 6 plus 6 is 12. 1 more would make 13. So that 6 and that 1 would make 7. So I think 7 plus 6 equals 13. 7 should go in my missing part. Now we're going to check that answer. I'm going to put my answer in the fill-in-the-blank sentence to see if it makes sense. There were 7 birds in the tree at first. I know that if I have 7 and 6, that makes 13. So it must be correct. Now, a common misunderstanding that you may have is that there is only one way to solve a problem. That is not true. There are lots of strategies you can use to solve word problems or compute equations. In fact, we could have solved our problem a different way by using subtraction. I could have looked at my model and started with my whole of 13. I could have subtracted 6 to figure out the other part. 13 take away 6 equals 7. And I still got the same answer. In this lesson, you have learned how to solve a problem with a missing part by drawing a bar model.
All right, so on this next part, you are going to need that worksheet and your pencil. We're going to work through these problems together. So we are going to practice drawing that bar model or that part-whole model, and we are going to chunk our problems and find the information and then figure out what the question is that we need to solve. So let's read the problem together first. There were some flowers growing in the garden. 9 more flowers popped up. Now there are 17 flowers in the garden. How many flowers were in the garden to begin with? So what is the question that they're asking us? how many flowers were in the garden to begin with? Are they asking us to find a part or a whole? Well, the flowers that were in the garden to begin with is not all of them because some more popped up. So we're missing a part here. So I should already be able to tell what kind of model or drawing I need to draw. Let's chunk this problem sentence by sentence. There were some flowers growing in the garden. Do we know how many were growing in the garden? No. In fact, that's the question they're asking us, is how many were there to begin with. But I am going to still draw a box, and that's our missing part. We're starting right with our missing part. Let's keep going. 9 more flowers popped up. So there were some flowers, and then 9 more popped up. So go ahead and draw the other part that we know 9 more popped up. Now there are 17 flowers in the garden. Does that tell us a part of the garden or how many were in the whole garden? That's our whole. So I'm going to create this bar for our whole. Our whole is going to be the same as our parts. That's why it's the same length. And there's 17. And then we have our question, how many flowers are in the garden to begin with? And that is the part that we're missing. Now we can use our model to write an equation, and we kind of talked about how there were 2 different ways that you could solve this problem. So the first equation that you could write would be to use addition. I'm going to start with my part 9, and I need to figure out what do I need to add to 9 that's going to equal the whole 17. 9 plus question mark equals 17. We could also use subtraction. So we could start with our whole that we know, 17, and we can subtract or take away the part we know. If we take away the 9, then we're going to be left with this missing part. Okay? Now, the question mark should be the same. If we get 2 different numbers here, then that tells us, uh-oh, we did something wrong. So we need to go back and check our math. What number do we need to add to 9 that would get to 17? Or if we count back 9 from 17, what is that answer? Well, just like she used her doubles, I know 9 plus 9 equals 18, and 17 is 1 less than that. So 1 less than 9 would be 8. I also know if I have 17 and I take away 9, well, 9 is really close to 10. If I take away 10 from 17, that would be 7, but it was a 9, not a 10, so we need to put that 1 back, and then that would give us 8. So we have 9 plus 8 equals 17, and 17 minus 9 equals 8. Remember, our answer is not complete without a label. What were we talking about in this word problem? Flowers. So that should answer our question, how many flowers were in the garden to begin with? 8 flowers were in the garden to begin with. Is this a reasonable answer? Well, if we start with 8 and then 9 more pop up, we end up with 17 in the garden. That pretty much makes sense. I know that when I did both of my equations, the addition and the subtraction, I got the same answer for my question marks. That helps me know it's reasonable. I know that 17 is about 20 and 9 is about 10, so 20 minus 10 would be about 10. So if I'm using what we call estimating to see if there's a reasonable answer, I know 8 is pretty close to 10, so there's a really good chance that that's the correct answer. Yes, that's a reasonable answer. All right, I'm going to have you help me with this next one. I'm going to read the problem all together, and then we're going to chunk it. On Monday, Tammy put 5 letters in the mail to her friends. On Tuesday, she mailed the rest of her letters. If altogether she mailed 15 letters, how many letters did she mail on Tuesday? Let's chunk this sentence by sentence and see what information we have. On Monday, Tammy put 5 letters in the mail to her friends. So we know on Monday, she put 5 letters in the mail to her friends. On Tuesday, she mailed the rest of her letters. Does it tell us how many she mailed on Tuesday? No, so I'm going to draw a box, but I'm just going to put my question mark in there. That makes me think I'm missing part of my answer. What was our question that we need to answer? How many letters did she mail on Tuesday? Is the letters that she mailed on Tuesday part or the whole? Tuesday is just a part because Monday is a part as well. So we do have a missing part here. Let's keep reading and see what other information we have. If altogether she mailed 15 letters, so it tells us altogether, that's our whole, she mailed how many? 15 letters. How many letters did she mail on Tuesday? That's our missing part. I want you to go ahead and write an equation on your paper that represents the model we just created. If you can do 2 equations, that's awesome. But use the equation that best works for you, that helps you understand the problem. We're just setting up an equation to help us calculate that answer. Okay, well, one equation you could have written is by adding. So we're going to start with the part 5. And we're going to think, what do I need to add to that 5 to get to our whole, which is 15? 5 plus blank equals 15. The other equation you could have written is taking the whole and then subtracting the part we do know to find the missing part. So we'll start with 15. We're going to take away the 5 that we know, and we're left with blank, that missing part. Go ahead, find your answer, and write your complete answer in the blank, and then I want you to think, is this a reasonable answer? What answer did you get? Well, I know that 10 more than 5 is 15. Those are nice friendly numbers to work with. And I also know if I have 15 and I take away 5, I'm going to be at 10 if I count back 5. So my answer is 10 letters. Don't forget your label. All right, let's think. Is this a reasonable answer? If she first mailed 5 letters and then she mailed 10 more letters, does that mean that she has 15 mailed in all? Yeah, that's reasonable. If we would have gotten the answer 20, that would not have been reasonable because it tells us that altogether she mailed 15. So there's no way that 20 could be the answer. So after you find that answer, go back and think about the problem and see if it makes sense. All right, we've got one more. Pam made 16 cookies and sat them on the counter. Her brother ate 4 of the cookies. Then Pam decided to eat 2 cookies as well. How many are left? I want you to draw your representation, draw a bar model to represent those parts. Chunk each sentence and put that in the model. And then stop there. Okay, let's look in chunks It starts by telling us Pam made 16 cookies and sat them on the counter. Let's find our question first. How many are left? So if we're wanting to know how many are left, is it asking for a part or does it sound like they're asking for the whole? Yeah, if something's left, it means some were taken or some were missing. So they're asking for a missing part here. So if Pam made 16 cookies and sat them on the counter, we're going to stop there. We're going to go ahead and draw that in our model. Now I don't know exactly if this is the part or the whole yet, so I'm just going to go ahead and put it down and we'll see from there. Her brother ate 4 of the cookies. Okay, well if he's eating 4 of them, that tells me that 16 is my whole, right? So he ate 4 of the cookies. Then Pam decided to eat 2 cookies as well. So she ate 2 cookies. How many are left? We still have a piece that's missing. So did you see here we actually have 3 parts to this problem? Okay, so 16 cookies were baked, and then part of them disappeared, 4, and then another part disappeared, 2, and then we need to know what's left. Okay, so now that we have our model, if your model didn't look like this, go ahead and fix that and use your model to write an equation to solve this problem. Remember, you can use addition or subtraction, but go ahead and write an equation with a question mark for the missing part. All right, so that would be 4 plus 2, oops, my 2 got a little crazy there, plus question mark equals 16 if you're going to use addition. Or you could use subtraction. 16 minus 4 minus 2, and that's going to leave us with our answer. Go ahead and calculate your answer. Well, I know that 16 minus 2 would be 14 minus the 4 would get me back to 10. I also know that 4 plus 2 is 6, and I need to add 10 to 6 to get to 16, so my answer is 10 cookies were left. Does this make sense? I know that 10 plus 2 is 12, plus 4 more would be 16. So in my head, I can quickly add those together and make sure that it's a reasonable answer. If maybe we did our subtraction or our addition wrong, it would give us an answer that wouldn't make sense if we thought about the story. All right, you did a fantastic job with me today. A way that you could practice using your part whole models is by doing a math snack. And you could get a handful of crackers and explore creating different bar model equations. If you have a total of 12 crackers and you put 4 in a group, try to figure out how many is in that missing part and then write an equation. All right, you guys have a fantastic day and I will see you next time.